Hi again, this is Sammy. I will be doing Math 12 again and continue with that exam that we started last time. So I'll try to finish it today. And that's it for this exam. We'll be covering a lot of trig identities, the ln, the natural log, I guess, and so on. So stay tuned. So here in this question, because we have e to the power of 3x plus 2 equals 5 to the power of x plus 1, what we need to do, we need to ln both sides. Ln is the natural log, and because ln e is 1, so if anytime you have e instead of log in both sides to bring the exponents down, you ln since we have an e. So now, you know, when we ln both sides, the exponents come down, so I'm going to do that right away. So 3x plus 2 ln e equals x plus 1 ln 5. So basically we ln both sides, then we brought the exponents down. Now what I'm going to do, ln e is 1, so I'm just going to cancel that. So I have 3x plus 2 equals x ln 5 plus ln 5. So all I'm doing is just distributing the ln 5 into the x and plus 1. Now what I'm going to do, I'm going to bring everything that has x's to one side. So I have 3x minus x ln 5 equals, I'm going to move the 2 to the other side, so it becomes -2 plus ln 5. Now take out x as the greatest common factor, and you're going to get 3 minus ln 5 equals -2 plus ln 5. Divide both sides by 3 minus ln 5 to isolate the x. That would cancel. And now we just put that in our calculator, and we'll end up with -0.281. That's the answer for this one. So here's another question that involves the ln, natural log. This is a little bit more challenging, and the reason is when you ln both sides. So if you ln both sides here, ln 5 brackets 3 to the x, close the bracket, equals ln e to the x minus 1. So here, if you will see this 5 times 3 to the x, and the rules, when you have two things that are multiplied, you have to expand them and you change them to addition. So you go ln 5 plus ln 3 to the x equals, I'm just going to bring the x minus 1 to the bottom here, and we have ln e. As we said, ln e is 1, so we cancel that. Now we have ln 5 equals, bring the x down, and you have ln 3 equals x minus 1. You know, this is plus, sorry. You know, the other one, I brought the x's all to one side and all of that stuff. Oh, you know what? Maybe I'll still do that even with this one. So what I'm going to do, I'm going to bring the x ln 3 to this side, and I'm going to bring the minus 1 to this side. So I have ln 5 minus 1 equals x minus ln x ln 3 ln 5 minus 1 equals, I'm going to take out x as the greatest common factor. I'm going to get 1 minus ln 3. Now, of course, divide both sides by 1 minus ln 3, 1 minus ln 3, and therefore x equals, and that's basically just a calculator question after that. And the answer, x equals -6.2 decimals, so 1.18. And that's the answer for this one. So here's one, it says log base 2x minus 4 plus log base 2x minus 3 equals 1. So here what you need to do, the first thing you need to do is combine the logs. So you have log base 2, and since it's addition right here, then you change this into x minus 4 times x minus 3. And this is part that the log rules equals 1. Now, after this, you see this is the base here of the log. You go the base to the power of 1 equals all of this to get rid of the log. So once you do that, you're going to get x minus 4, x minus 3 equals 2 to the 1. So basically, you change it from log to exponential function. So it was a log function. Now we change it to exponential function. Now FOIL this. And when you FOIL this, you're going to get x squared minus 3x minus 4x plus 12 equals 2. Move everything to one side and collect like terms at the same time. X squared minus 7x plus 10 equals 0. When you move the 2 to the other side, it becomes minus 2. And that's how this became 10. Now this factors into x minus 2. X minus 5 equals 0, and therefore x equals 2 and 5. We cannot accept these answers before we test them in the original function. So if we take 2 right here, 2 minus 4 is negative 2. Just know that you cannot log a negative number. You cannot log 0 or a negative number. So this has to be rejected. The 5 works here, so this becomes 1, and this becomes 2. So both the 5 works, both logs here. So 5 is your right answer. So x equals 5. Next question. Here we go. This is another question. A bacteria culture is grown according to the formula y equals 1000 e to the power 0.6 t, where t is the time in days. Determine the number of bacteria after 7 days. This is straight plug-in. So y is the number of bacteria, I guess. So y equals 1000 e to the 0.6 times the time, which is 7 days. And that just straight plug in. So 1000 times e to the power of 0.6 times 7. And it gives me 66,686 bacterium, or bacterias, or whatever the plural of bacteria is. So that's the answer for this. Now, how long will it take the bacteria to triple in size? So triple in size, this is your initial right here, 1000. Okay, so if it triples, that becomes 3000 equals 1000 e to the 0.6 t. Now, because this is e, I'm going to ln both sides. But you know what? Before I'm lning, I'm going to divide both sides by 1000. So a 0 cancels a 0 from here. Another 0 cancels this 0. Another 0 cancels this 0. So 3 divided by 1 is going to be 3. Just know that if you're dividing and there are zeros, you could do that. If there are zeros on both sides, you could do that. E to the 0.6 t. Now I'm going to ln both sides. So ln 3 equals 0.6 t ln e. So even though I'm lning both sides here, ln e is 1. So I'm just not going to write it. Now divide both sides by 0.6. And we have ln 3 divided by 0.6 equals. So it will take 1.8 of a day so almost 2 days to triple. So t here equals 1.83. All right, so let's move on to the next question. So here, determine all of the angles that are coterminal with 2 pi over 3 over the domain between negative 2 pi and 4 pi. So coterminal, what it means if you have an angle somewhere in here, this angle represented by, let's say, 2 pi over 3. So what happens if you make a full revolution and get back there? This is a coterminal angle, and you keep on doing that, and you get another coterminal angle. So you could do that indefinitely. Now also you could go backwards and get back there as well, and that would be another coterminal angle, except when you go backwards, it's minus 2 pi. So you know a full revolution is 2 pi. So if we want to get more coterminal angles, if we're going to get the positive ones first, I'm going to go 2 pi over 3 plus 2 pi. And 2 pi is the same as 6 pi over 3 if you want to do common denominator, which that gives me 8 pi over 3. 8 pi over 3 is still within the domain, because 8 divided by 3 is 2 point something. So this is one of them. Now what I'm going to do, I'm going to take the 8 pi over 3 also and add another revolution again, which is 2 pi, because going around all the way is 2 pi. And that's, again, we said that's 6 pi over 3, doing common denominators. And that's 14 pi over 3. Now 14 divided by 3 is 4 point something. Because 4 times 3 is 12. So we have to reject this. This cannot be, because it's going over 4 pi, because my domain is between negative 2 pi and 4 pi. So when we added 6 pi over 3 or 2 pi, we ended up with 14 over 3, which just went over the domain. So that cannot be done. Now take the original equation, the original angle right now, and take away 2 pi, which is 6 pi over 3 if we want to do common denominator, because 6 pi over 3 is 2 pi. And that gives me negative 4 pi over 3, still within the same domain. Now if we minus, so this is another answer as well, negative 4 pi. Now let's take negative 4 pi over 3 and take away another, like go one more round in the negative direction. So take away minus 2 pi, which is the same as negative 6 pi over 3. It gives me negative 10 pi over 3. Negative 10 divided by 3 is 3.3, which we went over that negative 3 points. So we went over, so this cannot be done. So we only have this answer and this answer for that. That's the best way to do it. Let's move on. So here determine all of the angles that are coterminal with negative 261 in general form. So negative 261, as I said earlier, it is an angle negative 261. So you're measuring this way, that's negative 180. Negative 261 just before negative 270 right there. So it should be right there. So if you want all the coterminal angles, well, there's one right here. Then there's another one, and there is another one. So they go on forever. You're not going to list all of them to infinity. So for general form, you just go negative 261 plus 2n pi, where n is a member of all integers. So what it means that n could be 1, that makes it 2 pi, and then you add another 2 pi will make it 4 pi, which n is 2, that will make it 4. Also, you could make n negative 1, which makes it negative 2 pi. So n just indicates how many rounds you're going to go. So n is saying you go 1 round or 2 rounds or 3 rounds or 4 revolutions or negative 1 revolution, negative 2 revolutions. So that's what it means. This is the, oops. Let me back up a little bit. See what I did here, what I did wrong. I said 2 pi, this is a degree measure. So this is wrong. We should write negative 261 plus n 360 degrees, because we're in degree measure, and there, where n is a member of all integers. All right, so determine the exact value of each of the following expressions. State the coterminal value. Where necessary, show all the work. So secant, that's the reciprocal of cos. So if cos is adjacent over hypotenuse, then the secant will be hypotenuse over adjacent. Your best bet here is to just draw your angle. A lot of students don't like working with radians. So if you don't like working with radians, just take the 2 pi, okay, over 3 multiplied by 180 over pi. So so negative 2 pi over 3 is the same as secant negative 120. For some of you who or most of you who don't like radians, you could just switch it to degrees, secant negative 120 degrees. If you want to know how I did that, I just negative 2 pi. I just went negative 2 pi over 3 times 180 over pi. And that's what gave me negative 120 here. Let me just that looks like 28. So I just want to make sure that I stick the degree right on top there. So negative 120, you're going in the negative direction. This is 180 right here. So it could be a negative 180. So if you're going this way, negative 120, you're right there in this quadrant. So now what you do, you bring a vertical. This is negative 120. You find your reference angle here. So 180 minus 120 is 60 degrees. So that's 60, that's 30. Now with the special angle triangle, the 30, 60, you know, that's 1, that's root 3, that's 2. So opposite to 60 is root 3. So opposite 60 is root 3. That's missing the negative right there. And opposite to 30 is negative 1, because the x-axis here is negative, the y-axis here is negative. That's why I indicated that. And the hypotenuse is always positive. Whenever you're doing these, the hypotenuse is always positive. So secant 120, as we said, is hypotenuse over adjacent, because the reciprocal of cos, that's adjacent over hypotenuse. So therefore, that would equal the hypotenuse is 2, and the adjacent is negative 1, which equals negative 2 as a final answer. Of course, you know, when you're dealing with the 120, you deal with the reference angle, which is the 60 here, and that's where you're working with, and that will give you the right answer. Okay, let's go on to the next question. So here it is, cotangent 630. So we got to figure out where 630 is. You know what I usually do? I just take the 630 and minus 360 to see how many rounds you go. So 630 minus 360 equals. So when I went 630 minus 360, which that means we went 360 way around. Now it tells me 270 left. So you go 270 more. And that's where your angle is. That's the 270 right here. So you know how this is 0, this is 90, this is 180. And you know how with the unit circle, that's 1 and 0. That's 0 and 1. That's negative 1 and 0. And that is 0 and negative 1. Now the tan equals y over x. So the cotangent will be x over y. And therefore, x over y will be 0 over negative 1, which gives you 0, because these are the coordinates. This is the x and this is the y value there. So cotangent 630 will be 0. All right, so let's go on, move on to the next question. So here's this question right here. It's graphing trig ratios. We know y equals a sine b x minus c plus d, where a is the amplitude, c is the phase shift, d is the vertical displacement, and b, a lot of students, when you ask them what's b, they say, oh, it's the period. No, b is not the period. B is to find the period. So the period equals 2 pi over b. So in this situation, I'm going to start doing this, and they're asking me to state the amplitude. The amplitude is 1/2. Never use the negative there. Never say the amplitude is -1/2. They'll mark you wrong. The amplitude is always the absolute value of this number. The phase shift, which is c. We don't have a phase shift. Usually the phase shift is right within the brackets here. So you'll have x minus something or x plus something. There's nothing added, or so the phase shift, you could say 0. So there's no phase shift. amplitude of domain, range, y-intercept, blah of the function. Okay, so let's find the period first. Period will be 2 pi divided by b, and b here is pi over 2. When you divide 2 pi by pi over 2, it gives you 4. So just 2 pi times 4, times 2 over pi, because when you're dividing by a fraction, you just flip it and change it to multiplication and flip that pi, so the pi's would cancel and you get 4. All right. Domain and range, if you want to tell them before the you graph it, the domain for sine and cosine is always all real numbers. So the domain x, e, r, was x is a member of all real numbers. The range is always the y is between the minimum and the max, okay? Because there's going to be a minimum to a graph, a max to the graph. If you have something like this, you know, there's a max, there's a min. That's what the range is from. The min, I'm just going to write that here if you want to. The minimum equals d minus a, and the max equals d plus a. Okay. So of course, a is the absolute value. So what's the vertical displacement is -1. So the minimum -1 minus a half is -1.5. And the max is -1 plus 0.5, which gives me 0.5. So that's your range right here. Now let's go and start planning to graph this. Now, what you do, graph one period first. So since the period is 4, so if I say 1, 2, 3, 4, here you don't have to worry about scaling, because when the period is in whole numbers like this instead of pi and all that stuff, then it's easy. You just know what everything is. But if, like, say the period was 2 pi over 3, then you don't know what every point is. So you have to multiply this by a quarter to find out what your scale factor is. You know, it'll be pi over 6, and you know you have to make every pi by into 6 segments and all of that. But in this question, we don't have to do that because you're dealing with whole numbers. It's easy to see the whole numbers. So the first thing I'm gonna do, I'm gonna graph a sine graph without any of these transformations. I'm just gonna graph one period. The only thing I'm gonna do is the amplitude, okay? So the sine graph starts at 0, and in a full period, it also stops at 0. So if anybody that wants to know how the sine graph looks like, the sine graph looks like this, between 0 and 2 pi. Okay, so the period is between 0 and 2 pi. Now the period is between 0 and 4. So, and also the middle will be right on the x-axis. The amplitude is half, so I'm gonna just go to where half is, and here I'm gonna go to where -half is, because that's where my points should be. Okay. Now what happens, if you look, we took care of this, okay, which is the amplitude. We took care of this, which is the period. So what we have that negative and we have down 1. So that negative is a reflection in the that negative is a reflection in the x-axis. So if I go to this one and reflect it over the x-axis, it's right on the x-axis, so it doesn't reflect. And then it's supposed to go down 1. So that point goes right here. This one here reflects over the x-axis, and then it goes down 1. So right there. This point reflects over the x-axis, it doesn't reflect, and then it goes down 1. So right there. This point here reflects over the x-axis, so it goes right there, and then it comes down. Sorry, hold on a second. What am I? Yeah. I'm just gonna put x's here so I don't mix up the points. Yeah, so this point here reflects over the x-axis, and then down 1, so it goes exactly what it is. So that's invariant, it doesn't change. And then this one doesn't reflect, and then goes down 1, which goes right there. So this is where all your points are, and this is how your graph is gonna look like. Wow, look at that curve. So that's how it looks like. Now, you know, because it moved down one, my x-axis basically, it's like my x-axis moved down one. So this is my baseline. That's what we call the baseline. And now if you want to graph more periods, sketch a following curve, blah, blah, inspect. So you could like, you know, if you're want to graph more of this, you know, the next thing you're going to go right here, and then you're going to come down to where the x-axis is, you know, and then you go down right there, and then you go back to where the x-axis is, and it continues, you know, the graph is continuous like that. Usually if you graph one period, unless they state differently. What's the y-intercept? The y-intercept is right here. It intercepts the y-axis at -1, so y-intercept equals -1. All right, so let's move on to the next question. Find the equation of the following. Okay, so as a cosine function, so here's as a cosine function, this is important because you know that for some of you who don't know, just know every wave you could express it as a sine or a cos, it doesn't matter. You know, like if you want to express, this is your baseline right here. So if I want to express it as a sine graph, I could start right here because the sine starts on the baseline and there is a full period, you know. A cosine, here they didn't specify if A has to be, negative or positive. So, or the, you know, the sign in front of the amplitude is negative or positive. So here, you could decide to start anywhere. So the cosine usually starts at a maximum. So if you look at the cosine graph, that's how the cosine graph looks like. You know, and so to here it's a full period up to 2 pi. This is the middle. So it starts at a max of 1 and it's the minimum is -1. So that's the cosine graph starts at the max. So what you want to do when you're trying to find the equation, you got to find the max in here with the lowest phase shift. You know, don't choose this as your starting point. So if the cosine starts right here, if that's your starting point, then this is a full wave right here. This is a full period and this is your end point. Now, you could either go 5 pi over 2 minus pi over 2, which gives you 2 pi, or just cheat and go, okay, this wave starts right here and finishes right here, so the period is 2 pi for the sine. If the period is 2 pi of the sine, don't think the period is going to change for the cosine, because the cosine, this wave have a constant period the whole time. It doesn't change. So that's why you could cheat sometimes, find where it meets the y-axis and where it stops, and then you don't have to go 5 pi over 2 minus pi over 2. This is between 0 and 2 pi, so the period is 2 pi. So if the period is 2 pi, then we know B is 1, because B is always 2 pi over the period. All right. And since the period is 2 pi divided by 2 pi is 1. Now the amplitude is always the height between the baseline, which is this one, to where it is the maximum right here. So if you see you scale them by 1 here, so the period, if you count it, that's -1 there, so it's 1, 2, 3. And since the cosine is starting at a max, it's 3 and it's positive in the front right here. Now we have cos. We ended up with B being 1, so we don't even have to write 1 here. I'm going to open a bracket and put X. My starting point starts at pi over 2. So that's your phase shift. The graph, instead of starting here, it started right there. Okay, so now it shifted pi over 2 to the right. So that's X minus pi over 2. And now my baseline, which is this one, this is my vertical displacement. This is my D. Where is that at? That's at -2. So my baseline here is y equals -2, my baseline. So that's where you shifted down to. And this is the equation for this graph. Let's move on to the next question. So there we go. I have a few more questions left. I thought I'll finish this today, but I'm tired and I want to go home. So I will finish it as soon as possible. Thanks for watching again. Till next time. Bye-bye.